Hello everybody, this is Bruce and welcome back to our next episode of Tableau Tips and Tricks, where we look at distance and bearing calculations. This workbook is a road trip planner where we have 531 different properties of the U.S. government, national parks, historic monuments. It allows us to enter our zip code, our starting point, our destination. This is the World War II memorial for our example. Tableau will calculate the bearing between the start point and the end point and highlight all of the properties that are along that route with a tolerance of plus or minus degrees. The user can expand or contract what they see based on those values. Let's take a look and see how we got there. First thing we need to do is look at our data sources. We have two data sources here. One is our shapefiles, which is a combined data source from both the U.S. Forest Service and the National Park Service. In addition, we have a Google Sheet, which is my personal favorite for non-enterprise data, where we have the attributes of those properties, and we'll talk a little bit about why we need both of those sheets in just a second. I'm not going to review all of the calculations in this workbook. This workbook is available for download at Tableau Public. There's a link below in the comments section. We'll hit some highlights here. If you have any questions or comments, please let me know and I'll help you out as I can. Again, we have two data sources. Let's look at the National Park Service and Forest Service shapefiles. We have a couple calculated fields, which will give us a join name, combining those data sources so we can connect those to our Google Sheet. We also have a joined shapefile field, which is a calculated field bringing together both of those shapefiles. One way we could do this is we can drag a shapefile for the National Park Service and we can drag a shapefile for the Forest Service. This presents some challenges. It's much easier just to drag one joined shapefile for our purposes. Dragging our joined shapefiles to our canvas, we will have a rendering of all of our 531 properties and their shapefiles. Looking at agency, dragging that to color, they are then rendered by National Park Service or U.S. Forest Service. Unfortunately, this will not allow us to do any of the complex calculations we have to do, and we are going to need latitude and longitude for each one of those. If we start a calculated field, and we try to drag a generated latitude or longitude, we are unable to do so. Fortunately, we have an answer. The automatic rendering of these marks is set to automatic, which will do a filled map. If we switch that to circles, that will show a centroid for all of those shapefiles. Here we have agency on color, so it's showing National Park Service and U.S. Forest Service. What we're going to want to do is take that join name, add it to detail, which will render us a map of all of the properties in our data set. A little bit of magic, highlight those, right click, select all, view data. And like magic, we have a generated latitude and longitude, which we can then export to a CSV file, copy and paste those values into a Google Sheet. And what we have is a discrete latitude and longitude. One of these is that. Latitude and longitude that are now in our Google Sheet, which is where the magic of the calculations happen. Once we have the latitude and longitude for everything in our data set, now we can start doing some calculations. Let's start with a basic distance calculation. If we right-click, look at the formula, you can see that this formula is looking at a from latitude, which is based off of parameter controls, and a latitude to each one of our properties. We also have longitude. This is the core calculation for distance in Tableau. We've done a slight modification by parameterizing that calculation, but it's something well worth looking at. The second calculation we have is bearing. Now, here's where we start to get a little complicated. As mentioned previously, all of the calculations that we are doing are based on the data source in our G Sheet, our Google Sheet, and we have joined on a join name to our other data source. Let's look at the bearing calculation. The basic bearing calculation is an A tan 2 calculation. That A tan 2 calculation takes into account two data points. We have an X and a Y point, and then we have to do a little magic with the degrees calculation. And one quick note here. If we look at Wikipedia, Wikipedia talks about the A tan2 calculation. The realization of the A tan2 function differs from one computer language to another. What does that mean to you? We have to make sure that we get the right syntax to make the math work. So we have a bearing X, we have a bearing Y, throw those together in a bearing calculation, wrap those in degrees, and that's the magic that makes this calculation work. Each of those bearing calculations has its own level of complexity. We're looking at sine, radians, cosines, latitude, longitude. Again, looking at the different parameter controls we have, your calculation may differ, but essentially what we are doing is calculating an A tan2 between two numbers, and those numbers are calculations in themselves, and the math is available in each of those calculated fields. Once we have our bearing calculation established, we have to use that bearing calculation to offset negative degrees. Some of those calculations end up negative deviation from true north, which is 0, so we have to convert those negative values to positive values and leave the positive values where they stand. This is the calculation that's required to do that. Now that we've got an understanding of a basic distance and bearing calculation, let's look at a couple of the other features of this dashboard that make the magic happen. First thing I want to talk about is our starting point. We have a parameter for start point, which we've set to a string, and we have, we're looking for a zip code here. In order to make this work, we have to go to our data source and we have to have each one of those zip codes with a latitude and longitude. That has made our 531 record data set over 40,000 data points. The only thing on those elements of zip code are a join name of the zip code, a latitude and a longitude. It's quite easy to just go out and Google latitude and longitude of US zip codes, download a 40,000 record CSV file, copy and paste that into our Google Sheet to round out our data set. That is the magic that makes the from calculation happen. Now, if we look at the magic on this planner map and we take off the filter, you're going to get a look at what's going on behind the scenes. We have 41,000 zip codes that are laying in the background. We have our start point, we have our end point, and then we've drawn some vectors and included only the attractions in that vector that meet our requirements. The circle of influence we have here is based on a parameter of how far are you willing to travel. We've not allowed the user to change this, but you can do it in the background if you'd like. We're going to talk about how we get to these angles of inclusion really quickly, and it's not that difficult. Once again, looking at the G sheet, we have our measures, and we are looking for a maximum bearing and a minimum bearing. Let's look at this calculation real quick. One thing that stands out is we have a bearing to destination, which we've calculated. We've added a course deviation, which is our parameter. The important thing here is this modulo 360 function. For those not familiar with this, it allows us to do things like calculate bearing, where we are going to 360 degrees. We add 1, we want it to be 1, not 361. That modulo function allows us to do that. Same thing goes for our minimum bearing. Once we have those in place, we're off to the races. Once we have all of our filters, highlights, colors, shapes, we're ready to go. Once again, back to our trip planner. We'll go full screen view. And let's change this down to Yellowstone, our first national park. And let's move to a Colorado zip code. And like magic, we're going from Denver up to Yellowstone. Once again, I hope you found this interesting, entertaining, and that you learned something. If you liked it, please comment, subscribe. If you have any tips and tricks on how I can make this visualization better, please let me know. I'd love to incorporate some of those changes. Once again, please visit the Tableau public link below, download this workbook, and you can really dig into the calculations. Thanks again. This is Bruce. Have a wonderful day.